Today's lesson is on section 9.2, multiply polynomials. First section in this chapter, 9.1, was talking about adding and subtracting polynomials together, something obviously we may have to do from time to time. Also, sometimes we'll have to multiply polynomials together to create some kind of simpler result or find an answer or be able to solve some kind of equation in the long run. One thing that'll be nice about multiplying polynomials is students will recognize the problem I have up here right now. This is a problem where we could multiply some polynomials together, and in the past we've actually called this the distributive property. So again, that is still what this is called. It's still distributing. I can still refer to it in that regard. So, but it's just know that this is something, again, when I multiply polynomials, this is a strategy I might have to use, something we have learned in the past. If I want to find the product of 2 times this binomial here, then remember what we do is I just have to make sure I multiply 2 times each of the terms inside that binomial. So 2 times 3x gives me 6x, and 2 times 9 gives me 18. So finding the product of that problem, multiplying that out, and again, that may help me get to something where I can solve it easier, solve this as an equation if it was, or maybe just simplifying it may help me collect like terms after that point. It may help me simplify the problem. So definitely something we've learned in the past, so being able to distribute. We've done that. This can also apply to what we're doing right now. Now I want to go to another page here in a second that emphasizes one thing, though, the difference between the first 2 sections we've done here, adding and subtracting polynomials, and then now working in this section, multiplying them. So I want to look at this page right now and refresh students' memory about, again, there's a difference between combining, these are different ways that we can simplify a problem, combining like terms or combining 2 terms to get 1 term sometimes. There are different ways we can go about it. Sometimes we can add and subtract. Sometimes we can multiply, and I just want to remind students how that can happen. When we're dealing with numbers like I have up here, these I am not too worried about, of course. 2 plus 3, this is still adding 2 monomials together. 2 plus 3 would give me 5. Over here on the other side, 2 times 3 gives me 6. So obviously, we're comfortable with that. But when we start throwing variables into some of these problems, then it's all of a sudden it gets a little trickier sometimes. And I just want to make sure students remember that when we're adding polynomials together or adding terms together, it's a different way we combine those as opposed to when we're multiplying 2 terms or multiplying variables and numbers together. So looking at this next one here, when I'm adding these 2 terms together, 4x plus 7x, again, something we've called that in the past, we call that collecting like terms, and yeah, we can still refer to it as that too. 4x plus 7x, since they each have the same variable part to them, we can just add the coefficients of each of these, and I can end up with 11x, and I keep that same variable part. So x is still my variable in that problem. If I go to the other problem here, though, now where I'm multiplying those 2 things together, 4x times 7x, again, there's a different way we combine these. Remember that 4 and x are also multiplied together. So I could also rewrite this as 4 times x times 7 times x. Really, all these things are multiplied to each other, all 4 of these things, each number and each variable. And when I multiply, I can multiply things in any order. So what we often end up doing is we just multiply the 2 numbers together. 4 times 7 gives me 28. And now when I'm multiplying x times x, remember that does end up doing something different than what I did on the left side there with adding polynomials. X times x means I'm taking some number times itself, and we have a way to represent that. We call that x squared. So this ends up being 28x squared. So we end up getting a different answer here than if we're just adding them together. I could plug in a number just to prove that, again, this works mathematically, but it's something to keep in mind when students now in this section are going to be adding sometimes, adding polynomials together or adding terms together, and when they'll be multiplying them sometimes. Let's say you're going over to this problem again here on this side. Let's say x equals 2. Again, just a reminder of how this does work. Okay, I could plug 2 into this top part of the problem, and this would then be 4 times 2 plus 7 times 2, and let's just see what I get in this case. We'll bring it up here just to get a little more space. 4 times 2 would give me 8, plus 7 times 2, which is 14, so this would end up equaling 22. So if I put x is 2, then my answer for this problem right here, I would end up getting 22 if I evaluate it. Well, let's evaluate it for the solution that I got as well. When I added the 2 like terms together, I got 11x. If I put 2 in there, 11 times 2 also gives me 22. So yeah, the 2 answers do link up. So it just shows when I'm adding two terms together, yeah, this is something mathematically we can do. I add the two coefficients, 7 plus 4, and I keep that same variable part though and get 11x. So this does work. When I'm multiplying, two terms together, in this case, and I can prove kind of the same thing over here also. If I have x equals 2, then in this case as well, I can show that, well, this will still work and be the same result here as it is to what I simplified it to, 28x squared. So this would be 4 times 2 times 7 times 2. And if I multiply that all together, well, I'm going to end up getting 4 times 2 is 8. And then times 7 would be 56. So let's see, 8 times 7, which is 56. Okay, I'm kind of running out of room here. And then times 2, which I think would be 112. Well, now I'll go into this problem here. What if x equals 2 in my 28x squared? 28 times 2 squared. 2 squared would be 4. 28 times 4, yep, would also be 112. So again, just showing it works mathematically, yes, it is true. But make sure we realize when we're adding or multiplying polynomials, two different things do happen there. There's two different ways we combine those kind of problems. We'll look at one more here on this page. Again, adding polynomials, and I kind of actually put this one up here as kind of a trick, and I'll see if students catch this in class. But if I have 3x squared plus 5x to the fourth, realize that I can actually combine those because they have different powers. This is x squared and this is x to the fourth, so I can't actually combine them. I can rewrite them though in decreasing degree order, so I could write 5x to the fourth and then 3x squared, but that's all I could do with those. I can't actually add those terms. They're not like terms. But when I go over to the multiplying side here, if I'm multiplying two things like this together, 3 times 5 will give me 15, and x squared times x to the fourth. Remember, we learned a rule earlier in chapter 8 that said when I have x squared times x to the fourth, I'm just going to add those two exponents and get x to the sixth. So this actually simplifies to 15x to the sixth. So again, just something to keep in mind as we're going through some of these problems. This is something I remind my linear classes and my intermediate classes that when you're doing problems like this, there's times when you're going to add and times when you're going to multiply terms. So we need to remember there's two different ways that we kind of go about that. So going back to that first page now, we talked about the distributive property, how we can use that. Well, now we'll use that in a couple examples here. And again, just remembering the things we did on that previous page, what happens when I multiply some of these terms together. So if I have this problem right here, it says find the product. It means I'm going to multiply. It says find the product of 4x times this trinomial here. It's got 3 terms, remember, so that's a trinomial. So I'm going to multiply 4x times each of those. So 4x times 3x squared, 4x times 6x, and 4x times 10. And just see what I get. 4x times 3x squared, well, 4 times 3 gives me 12. And x times x squared, well, again, now it's like I'm multiplying 3 x's together. I have x squared times another x. So that's like multiplying 3 different x's together. So that's that same number. So it's x to the third power now. Or again, I could think of like adding my exponents. 1 plus 2 gives me 3, using that rule from chapter 8. 4x times 6x would be just minus 24x squared, because again, when I take x times x, I'll get x squared for that middle term. And then 4x times 10, well, that would just be 4 times 10 gives me 40, and the x comes along with, so 40x. So that's what this one simplifies to, or can be multiplied to get that monomial times that trinomial. Same thing even if for any polynomial. And I'll get to that bottom line in a second here. But for any polynomial, if I'm going to use the distributive property, I just got to make sure I multiply it times each term in that polynomial, and I'll get my simplified answer. So negative 2y squared times 2y to the third. Negative 2 times 2 gives me negative 4. And y squared times y to the third, again, just bringing that off to the side. We learned a rule for that. We just add the two exponents, so I end up getting y to the fifth. Negative 2y squared times negative 4y. Negative times a negative gives me a positive, so positive 8. And then y squared times y squared, I add those together, those two exponents, and get y to the fourth. Negative 2y times y would just give me negative 2y still, but to the third power now, because I'm going to increase it by one more. And negative y squared times negative 3. Negative times negative gives me a positive. 2 times 3 gives me 6. And then the y squared comes along with. So again, all these problems right here, you might see some like these, where I have to use that distributive property like we learned a long time ago. So that is familiar. These all work when I have a monomial, again, something like this, just one term by itself, a monomial times some polynomial. I can just use that distributive property we learned. But what about if I have something else? What if I don't have just a monomial? That's something, again, that's something we've done in the past. But what if instead I have like a binomial, like 2x minus 9 times, let's say, 4x plus 5? Problems like this, something we'll see a little more when we get into intermediate algebra, is now where I'm multiplying a binomial times a binomial. I usually ask students in class if they can figure out what's going to happen in this type of problem, and they actually often can come up with the answer that is still kind of like distributing, but all I have to make sure that I do is I have to multiply each term in this first binomial by each term in the second binomial. So as long as each thing gets multiplied together, this will still work out. So it's still, in that regard, it's still kind of like distributing. So I take 2x times 4x and 2x times 5. I have to multiply that 2x, this term, by each of the ones in the other one. I've already got a drawn arrow, so I'll erase that one. But I have to multiply 2x times each term in that one. And also the minus 9. Again, think of it like negative 9 here, because there's a subtraction sign in front of it. But I have to multiply that times each of the terms in the other one. And then I'll have a bunch of terms that I can combine them and simplify my answer. So in general, what I've got written there in red, if you're taking notes along with me, is what I'd like you to write down. As long as you do that when you're multiplying binomials or trinomials together, you'll be able to get the right product. It says if you're multiplying polynomials, you just need to make sure you multiply each term of the first one by each term in the second one, and then combine like terms to get your simplified solution. The book has a few different methods you can use just to make sure you're organized and get everything multiplied together that you need to. And I'm going to pick out two of those methods to show you. I'll do one in this lesson and one in the next lesson. The one I'll talk about in this lesson that I like, and I didn't grow up with, but I have found this one in the book to be maybe even my favorite, is the table method. And again, it's just a way to organize and make sure that you multiply all the terms together that you need to. So think about what I did in that previous example. Again, it's a binomial times a binomial. And all I had to make sure I do was take 2x times 3x and 2x times the 9, and then also this 4 times each of those terms as well. Well, this table is a way of organizing that. And so I'll show you how this works, what you do to use the table method. I'm just going to take one of these binomials and put it up top here, and the other binomial, and then I'm going to stack it along the side here. And inside each box in the table is where I'm going to get my results when I multiply those terms together. Then I'll combine them all at the end, and that'll be my answer. So again, just kind of stacking everything up here. I wrote 2x plus 4 on the top. Again, one term on the left, one term on the right, and it's positive 4, so I just put 4. On the other one, it's 3x and then minus 9, so then made sure I put a negative 9 in front of it there, because that's really what I'm going to be multiplying. And now inside each square, I'm just going to put what's the result when I match up those rows and columns with each term. So like here I have 2x and then 3x, and that's going to go in this square. What's the result when I multiply those two together? So 2x times 3x, well, that would be 6x squared. In this box right here is what I'm going to get when I multiply 4 and 3x, because those are the two that link up for this box. So 3x times 4 gives me 12x. This one down here that I'm outlining, I'm going to multiply the negative 9 and the 2x. So 2x times negative 9 give me negative 18x. And then my last square, just when I multiply the two constants together, the negative 9 and the positive 4, which would give me negative 36. So now, I'm going to look at the results I have in the box here, in my table, and I'm going to write those terms in decreasing degree order, and I'll combine ones that I can, if that's possible. So the first one I see here is 6x squared, so I'm going to write that one down first. Then I've got negative 18x and positive 12x. Again, those are like terms. It's just like adding now. So I'm going to add those two together. Negative 18 plus 12 will give me negative 6x. So it's like I'm going to write minus 6. So now it's like, again, that's kind of like using our first section, combining like terms, or something we've done in the past. Cancel those out. Lastly, I have that minus 36 there, so I'm just going to write minus 36. So the table method, all it does is a nice way, a nice visual way to organize and make sure that we have multiplied together all the things that we need to multiply together. And that's why I do like this method a lot, actually. It's a very good visual way to make sure you get the right answer. Going through just another example here briefly. Again, I'm going to multiply these two binomials together. And it doesn't really matter, I know some students ask me, does it matter how you arrange the terms, like which one you put on the top and which one you put on the side? No, it does not really matter. So I could switch these around too if I wanted, but either way, again, it's just making sure that you multiply everything together. The terms in the first one by the terms in the second one and get a result. And then I'll collect like terms and simplify. So in this one, again, this top left box, I'm going to multiply 5x squared by negative x, and I'm getting negative 5x to the third when I do that. In this box right here, I'm going to multiply negative 2x and negative x. Well, negative times a negative gives me positive, so 2x squared. Down in the bottom left, 5x times 7 gives me 35x, squared, and it's squared also. And then 7 times negative 2x gives me negative 14x. So now that I've got all my terms, I'm going to collect them just like, again, like adding and subtracting them from the first section. Negative 5x to the third is my highest degree one, so I'm going to write that first. Then again, I can combine these two right here, 35 and 2x squared, to 37x squared. And minus 14x at the end. Then, one more I just want to talk about. I won't go through another example, but one thing I always ask students too at this point of the lesson, what if I'm multiplying a trinomial times a binomial? Let's say I'm multiplying something, and again, I won't go through this example right now, but just to make some space here. What if I'm multiplying some kind of trinomial, like 2x squared plus 7x plus 1 times 2x minus 5? So, what if I have three terms here in my polynomial, a trinomial times a binomial, or any other type of number polynomials multiplied together? Again, this table seems to work for 2 by 2, but I will show you it also can work for these models as well. It doesn't matter how many terms you would have in your polynomial, you can multiply them together with the table. And I'll show this by this next page here. I think I have an example that does this. If I happen to be multiplying a trinomial times a binomial, well, then I would just make a third column of boxes. Or a third row of boxes, either way actually would work. And I would just line up my trinomial on top like I did there. And then the 7x and the 10 there, my binomial. And I could still fill in the table and then combine like terms in the end to get my result.